Welcome back, everybody. Welcome back to EATS 280. You all look radiant and well rested. I have some bad news. We have an exam on Thursday. All right, so today we're going to study together. We'll do a bunch of practice problems that are like exam-style practice problems. That's all I got for announcements. I will go through a reminder of the exam logistics and what to expect. But other than that, any questions about class stuff? Then let's start studying. This should not be a surprise, any of this, the logistics. I just want to remind you. So Thursday at 7. And it's Michigan time, so it'll be an 80-minute exam. Thursday at 7. One time, I had this idea. I was teaching EATS 280 and EATS 281 at the same time. And they both have a midterm exam and one final exam. So I was like, oh, well, we'll offer both exams on the same night. So some Wednesday night in the middle of the semester, I booked every room on North Campus because we had about 1,000 students between EATS 280 and EATS 281, and there's about 2,000 seats on North Campus. So we had every room booked, and everybody got an email with what room they were supposed to go to, and I got the exams all started, and I had staff members that were proctoring them all, and I was in my office, and I had 2 chat windows open, one chat for my 280 staff and one for the 281 staff. So if we had to make a correction or something, all the rooms got the same information, so it was fair. And about 40 minutes into the exam, my 281 chat comes up with, somebody just ran out of the room in a panic. And then 3 minutes later on the 280 chat, somebody just ran into the room in a panic. So somebody had gone to the wrong room. In the end, we cut a deal. Anything they got right on the 281 exam, they got double credit for. Unfortunately, 2 times 0 is still 0. Yeah. So that is a story to remind you to come to North Campus at 7 p.m. on Thursday. You should have an email already with what room to go to. Did anybody not get an email about which room to go to? All right, great. So no lecture on Wednesday, some extra study time. No lab this week, some extra study time. And also the staff has to grade the exam, so they need the time too. All office hours after the exam are canceled again because we got to grade it. So focus on studying this week. Policies, this was in the email you should have gotten. So again, no surprises here. Closed book, closed notes. You can bring a cheat sheet, double-sided. The only requirement on the cheat sheet is that you should make your own cheat sheet. Don't have a copy of a friend's cheat sheet. This is in your best interest. Making a cheat sheet forces you to ask yourself the question, what are the most important 2 pages worth of information from 10 lectures? And when you think about that question, you think about all the material together, and that's like the definition of studying. So making the cheat sheet is a really useful way to study. Yeah?
Does it have to be handwritten?
Does it have to be handwritten? No. So if you want to shrink that thing down and bring a magnifying glass, go for it. Definitely bringing a magnifying glass. Yes? How much do I think the cheat sheet actually helps? So we're now going into straight up my opinion. My opinion is that the most valuable thing in the cheat sheet is making it. So when I was in school, if I had a class that didn't allow a cheat sheet, the first thing I did was make a cheat sheet and then throw it away. But different people have different styles. The point here is that in engineering and computer science, there's a lot of things we want you to understand but don't want you to memorize. So that's why the cheat sheet. More questions? All right, you won't need any calculators. Don't bring phones, iWatches, whatever. You don't need it. and the exams are given under the engineering honor code. Just a little reminder of the engineering honor code. There won't be a proctor in the room watching you. So will this be the first engineering exam for anybody in the room? Okay, so some people yes, some people no. Basically, in engineering, we trust you. So no proctor in the room. You can come outside and ask questions. The staff will be outside. We will have an honor pledge on the exam that says this, and we'll ask you to sign it, attesting that you have taken the exam honestly. So that's it. Honor code violations related to exams are don't come super often, but when they do, it's pretty bad. So that's that. So how do I study for the exam? Step 1, go to class on Monday where we do an exam review. There's exams and solutions to practice exams posted on Google Drive. You can use those to study. You can use the labs, including the optional exercises, to study lecture slides, including the exercises from lecture, the textbook, and study groups. Something that is really important in programming exams is that when you're studying, you do things in addition to reading things, because you know for sure that on the exam you'll have to solve problems that you haven't seen before. And solving problems while you're studying is the most useful way to replicate what you're going to see on the exam. All right, so the biggest question, what is on the exam? I will tell you exactly what is on the exam. Lectures 1 through 10, that's all the topics up to and including polymorphism. And if I had to break it down into 4 things, like meta topics you should really focus on: pointers and arrays and what they look like in memory. Strings and C strings. We love putting questions about C strings on the exam because it's good practice for future job interviews. Abstract data types, including C style and C++ style. And polymorphism. We rearranged the topics a little bit in the fall. So some of the practice exams, the topics are a little bit off. The practice midterms that we posted, if you see any questions about recursion, lists, or trees, you're not crazy. Just ignore those. That's kind of like back to the student who came into the 281 exam. I can only imagine what it would be like looking at this. She's like, I've never even heard of these words before. So if you haven't heard of recursion, lists, or trees, it's okay. We're going to cover it later. If you run into any practice final exams, you can ignore anything, or rather you can look at stuff that has to do with derived classes, inheritance, polymorphism. This is the topic rearrangement we made recently. All right, can I answer any questions about the logistics stuff before we get into practice problems? Say that again? Are debuggers on the exam? You mean, can you use a debugger on the exam? That would be awesome. Because then you could just see if you got the right answer, but it'd probably take longer. You mean will we ask you questions about debuggers? So anything that's in lecture or lab is fair game. We do make an effort to focus the most of the exam on the things we focus the most on in projects and lecture. Any more questions about logistics and topics? All right, then let's practice. Does anybody know what this is? This is Charles Babbage's computer. This is a mechanical computer. It was a early conceptual predecessor to electronic computers. It did multiplication and division, did arithmetic. So it's a big calculator. This is as big as a room. Okay, let's practice. I'll give you a few minutes, and then we'll talk about the answers.
the 280.
All right, let's take a look. When we draw our memory diagrams, anything that goes in a box like this, what do we call that? An object. A piece of data in memory. A little bit more in depth. Does that line of code make a new variable? Yes. Does it make a new object? Agreed. It's a second name for an existing object. So pointers and references are a good way to think about, oh, do I really understand the machine model? Do I know what's an object and what's not an object? All right, objects live at addresses. Every object has an address. Like, say, addresses are purple usually. That's a joke. Like OX4. Lifetimes. When do objects come into your program and when do they go away? What kind of objects live for the whole program? Global variables. And then what lives during the execution of a local block, like a function? Local. And we learned about a new kind of variable recently where you get to control the lifetime. What is it? Dynamic. All right. So which ones are managed by the compiler? These ones. I will post the answers after lecture so that you can use them to study. Any questions on this one? Will dynamic variables be on the exam? We are only covering up to lecture 10. We did learn the fact that dynamic variables exist when we talked about machine model, but we didn't, and we used them a little bit in project 3, but that's as far as we covered prior to the midterm. Good. Yeah, it's important to know. All right, let's talk about procedural abstraction, like making peanut butter and jelly sandwiches. I'll give you a few minutes on this one. All right, let's take a look. Abstraction, separating. What are we separating? What a procedure does from how it is implemented. In C++, what do we use to implement procedural abstraction? Functions. Data abstraction. What do we use to implement data abstraction in C and C++? Class, and there's a second valid answer. Struct. Cool. Project 1, where do we usually describe the abstraction? In other words, what? In header files. So this is the computer science concept, abstraction, and how C++ implemented that computer science concept, header files. Any more questions on this one? Then let's talk about pointers. We'll get a little less memorize-y and more problem-solvey after we take in this comic. Okay, I will give you a good chunk of time to work on this. and make some implementations. So let's say we call find on, we'll make an array like this. And then we can call find on it like this. My array, how big is my array? It's 3. And let's say we're looking for, I don't know, 17. So in memory, we get something like this. 1, 2, 3. And then that's, when we call find, A points here. And then we get another object size. And the value of size is 3. Everybody with me? So this is what memory, oh yeah, and we get another object called search, and search is 17. So this is what we start with. So now we need to visit each item in the array. If we know the size, we could use a for loop. We could also use a while loop. I'll do it with a for loop. So what's wrong? That's bad. Well, it's not following the instructions is the problem. That's going to be using traversal by index. Instead, I need to use traversal by pointer. So what type should I use to visit each item in the array? A pointer, like this. What's wrong now? Okay. How do I get the address of the first thing in the array? Okay, done. And then how do I know when I'm finished? When a plus size, or while a plus size is less than, oops. I could have done something really confusing and done like greater than I, but I'm not going to do that. All right, well, I is less than a plus size. And then how do I go to the next thing in memory? Increment I. All right. Everybody with me on this so far? So now I've got an I, and I points to the same place that A points to. How do I figure out which ones I care about? All right, I'm going to make a mistake. How about I make 2 mistakes? What's the first mistake? 17. Like, am I always looking for 17? No. Okay. What mistake did I make here? I is a pointer, and search is a integer. The types don't match. So how do I fix this? Dereference. Excellent. What do I want to do if I found what I'm looking for? Return. What type does my function expect me to return? A pointer. And what type is I? A pointer, so I can just do that. All right, oh, yes. Why does A point to the 3 instead of the 1? Because I made a mistake. Thank you. So the small addresses are down here, and the big addresses are up here. Is this on the heap? This is on the stack. Does the stack grow down? Yes. Are the big addresses at the top of the page? Yes. So this would be like address, OX4, OX8, OXC. So it's like bigger addresses. Are you with me that the first element in the array has an address? Are you with me that the last element in an array has an address? Are you with me that the address of the first element in the array is smaller than the address of the last element in the array? Does the stack go down instead of go up? When we add a new stack frame, do we add it Yeah, the stack grows down means when we add a new frame, the stack frame goes on my picture below the previous frame. But not for each object. Here, I got another question. This is a valuable discussion to have. So when you add a new stack frame, will the addresses in that stack frame be smaller addresses or bigger addresses than in the most recent stack frame? Smaller addresses. Oh, that would be an amazing test question. I would just print out a bunch of pointers and be like, which stack frame got called first? Okay, I'm missing one thing. If I didn't find it, then I can return I can return null PTR, or null, or 0. More questions on this one? Yeah. Is that the specific syntax for a null pointer? Yes. Yep, I'm being literal here. Is that the same as returning 0? Almost. Null PTR has a type. That's the difference. 0 is a integer that gets recast to a pointer type. Null PTR is 0, and it has the type of I'm a pointer. Would it be incorrect to do it this way? This would be fine. This is how C programmers do it. C++ style programmers use the null PTR. Should we bother with assertions? If we want you to use assertions, we'll be really specific about it. Since we're not actually going to run your programs, it's probably in your best interest to just forget about the assertions. But you're also welcome to add comments. Be like, I'm assuming that blah, blah, blah is true right here. Since real humans grade your exam, we read everything you wrote. Yeah?
You did everything on like one line, kind of. Would it be fine if we used like curly braces and broke it up in one line?
Would it be fine if we use curly braces and break it up on more than one line? Yep. This is just sort of my style. Anything that's valid C++ is valid for the exam.
Can you explain the I less than a minus size? Like why you chose?
Oh yeah, why did I choose this part right here? So let's first say, what is a plus size? So a plus size points just past the end of an array, like right here. I starts by pointing at the beginning of the array, and then we do plus plus, and then it points here. And then we do plus plus, and then I points here. And then we do plus plus, and I points just past the end. At that point, is I less than or equal to a plus size? True or false? False. Which is good because we almost went off the end of the array, but we stopped short of doing anything about it.
Thank you. So is it valid instead to have done I is 0 and then not indexed but just made a pointer to?
So the question was, what if I did an integer I and then I incremented a pointer? We'd ding you a few points on that because the whole point is to not use integers. The point of this way of thinking about the code is to know that everything's an address and use pointer arithmetic on the addresses. That's like the kind of understanding that we're going for.
Explain why it's not a tight mismatch to add size to a pointer.
So when you do a plus size, the type of a is pointer. The type of size is integer. Those types are related, but they're not the same. So like, why can you do that? The compiler specifically implements plus operator for those two types. And what it really, really means is go to the next integer in memory. So this is back to like, what is an address, how big are objects, and the size of operator. So the compiler knows how big the objects are, and it knows to go to the next one. All right, these are typed out answers. And this one is the answer for the string version. The C string version, let me just point out a couple of differences here. Well, first let me point out something that's not different. We're still using a loop. We are still incrementing a pointer. We are still using an if statement that checks against the search. And we're still returning a pointer if it's found. All that's the same as before. Now let me show you something that's different than before. There's no size. Why don't I need a size in this example? Because it's a null terminated C string, aka sentinel, a sentinel character. That's like a special case in C strings. It's like, hey, I'm at the end. Why didn't I do that with the array before, the int array? Because like what int would I use to mean I'm at the end? 0? I don't know. What if I need 0? Oh, how about -1? And, wait. Nobody uses -18, at least not very often. See what I mean? All right. So now we can just we can dereference this pointer, and when I dereference \0, I get 0, aka false. Yeah. Could you also do this? Yes, and that would be totally fine.
Could another organization be you have an extra variable that's a character, a pointer to a character, and you set it equal to null pointer in the beginning, use a break statement and if, and then return whatever.
Let's talk about it after class. There is more than one correct solution to lots of these C-string problems.
In this function, it's like you change the char pointer as directly. After you run it, do you like lose the original string?
So the question was, I am reusing this variable. Is that gonna like make me lose track of where the original string lives in memory? Good question. So here's my string in memory. How about hello? And I start off with, I don't know, x points to hello. And then I call stircher x and e. So now I have a second variable, s, that points to h. Pointers pass by value, right? So is s the original pointer to the string, or is s a copy of the pointer? S is a copy of the pointer. So I'm modifying a copy of the pointer. And then when the function finishes, what happens to s? Goes away. That's why I can get away with this. And this is like a trick that C programmers often use.
So when we're using the for loop ones, we don't have to assign to int char s. We can just directly just for.
When I did the for loop version, could I
Just
directly use A? Here's the reason why I can't. Because I got to remember how to find the end. One more before we go on.
On the next slide, or when you had before in the red, while star s is not equal to the null pointer, is that the same as saying star s is not equal to 0?
Is this thing the same as this thing? Yes. So tick \0 is exactly the same thing as the number 0. And another way you could find this, if you Google ASCII table, you'll see in that row the ASCII table. You could confirm that.
Cool. Thank you.
All right. I think we need a break. Let's take 5 minutes. All right, I think it's been 5 minutes, so let's keep studying. I want to make sure we have enough time to get through all the different topics, and we already talked about C strings, so I'm going to skip this one to try to make sure we cover all the topics. And I will publish the answers later. All right. Let's talk about Bjarne. Have I ever showed you this picture before? Yeah. Bjarne Strustrup, creator of C++. I wonder what year this was. You can kind of like tell a little bit from the CRT style monitors and desktop computers. All right, let's talk about C-style abstract data types. Please call this function on each triangle in this array using traversal by pointer. All right, let's code this up. So this is pretty similar to the problem we did earlier with the array of integers. We know the size ahead of time, so we can use a for loop. Now, instead of using a pointer to an integer, we need a pointer to a triangle. And we want to start at the beginning of the array. The beginning of the array is that, because it points to the first element in the array. So triangles points to the first element in the array. How do I know if I'm at the end? Triangles plus size will give me a pointer to just past the end. So now I can compare this. Triangles plus size. And now I just need to increment the pointer. All right, when I increment my pointer, do I need to, do you agree that one triangle object is clearly more than 1 byte? Do I need to increment by 2 bytes or like 3 bytes or 3 times size of double bytes? Why not? Because the compiler does it for me. The compiler knows how big a triangle is. This is why it's important that pointers know what kind of pointer they point to. So the compiler knows that I is a pointer to a triangle. It uses that information to go the correct number of bytes forward in memory when I increment it. Yeah. Does this work for inherited classes? If you have a shape pointer and you're incrementing a triangle, what gives? Because there could be different sizes. I'll answer your question with a question. How many bytes is a pointer to an integer? The answer is 8. Okay, how many bytes is a pointer to a triangle? 8. How many bytes is a pointer to a shape? 8. That's why you can, if you have an array of pointers, it's okay that they point to different things. That's how pointers and polymorphism all in the same container work. But the objects have to live somewhere else, not in the array. If you add 1 to a pointer, does it move the right number of spots? That is always true. The compiler always knows what the pointer points to, and it knows that they're next door neighbors in an array, so it goes to the next slot in the array. No matter what is in the array, even if it's an array of pointers. Even if it's an array of pointers. So now I can call my triangle area function. And triangle area expects a pointer as an input. What's the type of I? Pointer. The types match, so I can use simple syntax without extra stars and ampersands. I see some victory dances out there. Somebody must have gotten the right answer. Yes?
Does it need to point to a const triangle?
Oh, yeah. Let's see. This function promises not to modify t. I use triangle star I. Triangle star I says, hey, you can modify what I points to. Can I pass a regular pointer into a function that expects a const pointer? Yes. Because if I modify the triangle that I points to, I is like, yeah, sure, whatever, I don't care. And so if I pass I into triangle area is like, I know you don't really care if I modify this, but I'm not going to modify it. What if I reversed it? Would that be a problem? That would be a problem. Would it be equally correct for me to add const triangle star I? Yes, that would be equally correct. More questions? Then here we go. I'll give you 60 seconds to think about this one. All right, what is wrong? We messed up the class's internal representation of a triangle. So we broke the representation invariant. A reminder, representation invariant is a fancy word for sanity check, a sanity check for the member variables. The member variables are the representation. The representation invariant is what always has to be true about the representation. So sanity check for the member variables. We fixed this in class by using private member variables. So programmers who use our triangle class can't modify these private member variables. The member functions are public, and it's okay for another user to use the member function. Then it's okay for the member function to modify a private member variable. The point is, you as the programmer who write the triangle class, you write the member function, so you get complete control over what happens to the member variables, because the member functions are written by you, and the member functions modify the member variables. But if you try to use it from the outside, like in a main function, you can't access the private member variables. But you can access the public members. Public members, private members. So that's a quick review of public and private. So now let's move on to derived classes and polymorphism. I'll give you a couple minutes. All right, static type versus dynamic type. So one of these you can tell by reading one line of code. What can we tell by reading the line of code? Static or dynamic? Static type. We can tell the static type by reading this. And the static type, means compile time. And the compiler is really good at reading the code. So this makes sense. The compiler is terrible at reading your mind. And that's why the compiler has no idea what the user is going to enter. And that's why the compiler has no idea that the dynamic type in this example is isosceles. The only way to know what the dynamic type is to know what the user entered. So it's impossible to know that at compile time. Questions on the difference between static type and dynamic type? So we added a shape class in our lectures about polymorphism, and we needed a way to have one collection of objects that all related to each other, but we needed a way to get triangle and rectangle to relate to each other. So we added this shape class, but it didn't really make sense to make a shape object, so we made it an abstract base class. I added output messages to all of the constructors, like this. So assume we've got these messages for all of our constructors. What is the output of this code? Is the output. So first we got to ask ourselves, when do constructors run? Constructors run when we create an object. Hey, we're using that terminology from the first slide. Do I create an object on this line of code? Yes. Do I create an object on this line of code? Well, let me be a little more specific. Do I create some kind of a shape object on the second line of code? No. I do create an object. It's a pointer. Do I need to run constructors to create a new pointer? No. I need to run constructors to make a new shape object. All right. So to answer this line of code, we have to look at the diagram. This is number 1. This is number 2. This is number 3. Can I stop? Yep, because I wanted an isosceles. So the output is shape, triangle, isosceles. Questions so far? What does a stack frame look like when you create classes? It actually does call stack frames. They pile on and then they pile off.
Is it the case that like isosceles would start first, but then it immediately calls the next one up? So they start in reverse order in which they finish?
Let's talk about it after class. What I really want, I want to focus on the most important stuff because there's a lot of material here. Understanding what order constructors execute. That's the important concept here. And understanding that we use constructors most commonly to make sure that the member variables get initialized. Because that's a fundamental problem in C and C++. If you don't initialize the member variable, like if you forget, you can get whacked out results where two computers get two different answers. Did anybody experience this on a project? It's pretty painful to debug stuff like that. That's why Bjarne was like, oh, let's make a constructor. So no output here. This line of code. Is there a custom constructor for isosceles? Yes. Is there a custom constructor for triangle? Yes. Is there a custom constructor for shape? No. Do we still need a constructor? Yes. Something has to run. So it'll be the default constructor. So shape, default, triangle double, isosceles double constructor.
This is kind of related and kind of unrelated. Is a pointer an object, or is it?
Is a pointer an object? Yes, this is a related question. Yes, a pointer is an object. An object is anything in memory. I got a question for you. Is a reference an object?
Yes.
No. Sorry, I put you on the spot. A reference is a second name for an object that's already there. Studying the difference between pointers and references can help you get a better understanding of that machine model. Yeah? So the question was, when the constructor runs, can you assume that the object follows the representation invariant? No. You can think about the input of a constructor as a formless blob of memory. And the job of the constructor is to make sure that the representation invariant is true by the time the constructor is finished. So could you put a check in the constructor? You could at the very end. You could put a check at the very end of the constructor to make sure that when the constructor is done doing its work, the representation invariant is true. Let's do one more. almost to the end of our study session. It's helpful to remember the is-a relationship to answer these questions. When you look at this diagram, whenever you see an up arrow, that's an is-a relationship. Makes sense in code, and it also makes sense in English. A rectangle is a shape, true. A triangle is a shape, true. A rectangle is a triangle, false. So this is not going to compile. Okay, isosceles create an object. That's going to print a bunch of messages. We already covered that. An isosceles is equilateral. Sometimes is sometimes good enough for a compiler. No, compilers want just serious commitment. So this is a downcast. I promise you will get out on time. I promise. I promise. So an isosceles is equilateral. That's not always true, but it's trying to use the diagram this way. It doesn't make sense in English. It also doesn't make sense to the compiler. And looking at it on the diagram, you can see that it goes down. It's a downcast. That's another explanation for why this doesn't compile. So I'm going to finish up here. May what you study be what is on the exam. And see you on Thursday night.